Welcome to Basic Brewing Radio for Thursday, April 29th, 2010. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. Well, this week, home brewer Jeff Karpinski joins us to talk about brewing with electricity. You may have read Jeff's article in BYO about his countertop brewing system. He'll talk to us about that and about building heat sticks. If you're new to home brewing and would like to get into the hobby for the first time, check out our website, basicbrewing.com, where you can find archives of our audio and video podcasts and our DVDs to walk you through basic and more advanced brewing techniques. And you can follow me on Twitter. I'm Basic Brewing, all one word. You can find me on Facebook at facebook.com/basicbrewing.james, and you can find our show at facebook.com/basicbrewing. Thanks to everybody clicking on the Amazon.com associate link on our basicbrewing.com site. Whenever you think of Amazon, think of us and click on our associate link first. It won't cost you any extra, and you'll be helping us to bring you this show, and we appreciate your support greatly. We also have associate links for Brew Your Own magazine and the American Homebrewers Association on our site, too. And there's more. You can now find our iPhone app, our Basic Brewing iPhone app on the iTunes Store. The app is a tool that you can use to view and hear both our audio and video podcasts in one place. And I'll be putting extra stuff on there connected with each episode. So just search for Basic Brewing on iTunes, and you can find the app. And we've gotten some good feedback so far, so I appreciate those who have downloaded it. It's just a couple of bucks. Let's take a very quick look into the mailbag before we talk to Jeff. Jean-Luc writes in with a correction. He says, on correcting my pronunciation of a word last week, he says, I often work with carrageenan. It's pronounced carrageenan, and the "gee" sounds like geek. What are you saying? Oh. He says, I was a bit surprised of your pronunciation. You usually strive to get the correct pronunciation of each city and every word. And, well, I do. I do try. So I guess I pronounced it carrageenan last week. So thanks for that. And not familiar with that substance, carrageenan. I'll know better next time. This comes from Trevor. Trevor says, I was listening to the BBR BYO Experiment 3 roundup today and was amused to hear Steve bring up Shakespeare. The Shakespeare quote, brevity is the soul of wit. When designing recipes, I tend to think of the name of the beer first, then design a recipe around that. It's more fun that way. Anyway, Trevor says, I've been working on a recipe for a wit beer I'm calling Brevity. Well, there you go. He says the wit I'm currently aging is a low-finish gravity beer called a dry wit. I guess you could do a small batch of that and call it a half wit. Or you could do it in the dark, call it a dim wit. This comes from John. John says, I performed my own unintentional experiment. I made an ale where I added 1 ounce of coriander seed with 15 minutes left in the boil. At the end of the night, I noticed my remaining coriander supply had a fair number of tiny beetles in it. The wort is fermenting now, but I don't know if I can bring myself to keep it. Some people point out that many food products have, quote-unquote, acceptable amounts of bugs and parts in them. Also, I imagine people use hops and malt grains containing a certain amount. What's your opinion? Well, John, it sort of reminds me of the old joke. What's worse than biting into an apple and seeing a worm? Biting into an apple and seeing half a worm. Even if some of the bugs did get into the beer, you boil them for 15 minutes, so they're clean bugs now. I personally wouldn't worry about it. And in some parts of the world, insects are a delicacy or even a staple of the diet. And on a recent trip to a state park in Arkansas, we found packages of crickets, real dead crickets in the gift shop, and they were flavored with ranch and barbecue. So we bought a package of the ranch crickets and mustered up the courage to eat a couple of them, and they were pretty dry, but not entirely repulsive, I must say. So, all that to say, I wouldn't worry about it. Well, what do you think? If you have bugs in your beer or bee in your bonnet, you can write me at james@basicbrewing.com or just use the contact form on basicbrewing.com. And please don't forget to tell us where you're from. Even if you've written me before, I'm getting older. I don't remember like I used to. So, Jean-Luc, Trevor, and John, don't forget to tell us where you're from. Now, let's move on to our chat with Jeff Karpinski on brewing with electricity. Well, Jeff Karpinski, welcome to Basic Brewing Radio.
Oh, thank you, James.
Now, you're here because we want to talk about electric brewing. So, give us some background on your experience with electric brewing and your experience with brewing in general.
Well, most people probably would consider me a newbie. I started brewing back in late 2006 with Mr. Beer. Played around with about a year with various Mr. Beer recipes and had a blast with that. But all my life I've been the cook of the house, and so I started getting bored with the extract stuff, and started experimenting with some grains. The typical progression that a lot of homebrewers go through, and then by the end of 2007, I was really starting to get the itch to go all grain. But like most homebrewers, I didn't want to go outside. I didn't want to be out in the garage. I live in Colorado, and it gets really cold in the winter. So I enjoy brewing in the kitchen, and I'm fortunate enough to have a spouse who doesn't mind the smell. I know that's a common complaint. But figured I wanted something where I could continue to brew in my kitchen, but be able to do all grain, being able to do full mashes, boils, and so forth. The other interesting quirk with me is I love beer, but I tend to have a short attention span. So 5-gallon batches is too much for me. I don't have a lot of friends nearby to share with. I'm very rural, so I wanted something that I could scale down, maybe brew twice a month. The 3 to 4 gallons seemed to be my sweet spot. So I started looking at what was out there as far as brewing systems and what I could design and scale back, and electricity seemed to be the right fit for me.
And you've designed a system and written an article in Brew Your Own magazine, a system designed or based on Lonnie McAllister's Brutus 10 system, right?
Actually, his Brutus 20 is his ugly stepchild. And we can cover it a bit later, but basically the interesting parts about it is basically a 2-vessel system, which really made it ideally suited for indoors. I mean, you basically got a kettle and you got a mash tun. It's no sparge, so it takes a lot of variability and skill out of, hitting certain numbers. I mean, in some aspects, the no sparge is almost like the brew in a bag concept, where you plan everything up front, your total water volumes, so it makes it very easy to predict, what your original gravity should be and reach those numbers. Plus, being a 2-vessel system, it fits nicely neat on the counter. It's just ideal for indoor brewing.
Now, before we get too far into it, we probably should have a disclaimer about electricity, in that whenever you combine electricity and water, you really need to know what you're doing. So what can you tell people to ensure that they are safe?
I think, first and foremost is be absolutely certain that you're working on circuits that are ground fault interrupt protected. I mean, any modern kitchen, all your outlets in there are going to be, GFCI protected. I mean, if you were going larger and running a circuit out to your garage, you want to make sure that you get a breaker that has built-in GFCI. I mean, that's the key. I mean, having a ground on your equipment is of course important, but the key to remember is grounds protect property. GFCI protects humans. So that's probably the first and foremost the key thing to have.
How can you tell if a circuit is GFCI protected?
In your kitchen, your outlets should have a little test button right on them so that you can actually verify the proper operation. If you're installing your own, of course, then you buy the circuit breaker, at Home Depot or Lowe's or whatever that has it built in, or work with your electrician. Bribe your neighbor electrician with some homebrew and have him do the stuff for you.
And sometimes an outlet may be protected, and you might not know it. Like, for instance, in the room next to my bathroom, there's a plug that's on the same circuit as one that's ground protected, and I didn't realize it until I tripped it accidentally, and I couldn't figure out what was going on, and then pressed the button in the other room, and it worked again. So it may take a little research to figure out if you're being safe.
Yep, and I think there's some testers available that you can actually plug into the outlet and will simulate a ground fault test to verify that things are working as they're supposed to. A disclaimer: I'm not an electrician, I'm not licensed in any way, but I do know from reading the various codes. I mean, pretty much any house built beyond the mid '70s. I mean, in the United States, the code dictates that kitchens have two 20 amp circuits that are ground fault interrupt protected that are dedicated solely for small appliances. So, strange as it may seem, your kitchen's actually a pretty good place probably to be doing electric brewing.
And also, like for instance, I have a plug on my porch that's also protected in that way. So if you wanted to use, say, a heat stick to boost your heating power of your propane, you might be able to do that safely as well outside too.
Your discovery there in your bathroom, my house is like that outside. All of my outside outlets and my garage outlets are all on one circuit that is GFCI protected, but I also have my beer fridge on it. So the beer fridge and the air compressor of the garage go off at the same time. Things trip.
It reminds me of a Green Acres episode, but that's another. You can't have two things that add up to more than 7 on the circuit at the same time.
Exactly. I did want to touch briefly on electricity versus propane.
Sure.
Most home brewers have a pretty high comfort level with propane. Their turkey fryers or burners and a nice big kettle out outdoors and so forth. I guess from my perspective, I live in a very rural area, and so most of our energy is from propane. Heat and so forth. And I've seen firsthand, what propane can do when it goes wrong. I've seen a house literally turned into toothpicks.
Wow.
And to me, I guess I'm not, experiencing that. I'm thinking, well, I got this, tank of propane that can level my house versus, an electric element that can give me a zap, but I'm gonna opt for the electricity.
Now, I tweeted out there and asking for questions on electric brewing, and I got a couple of questions. One from Andy Sparks, and he asks, heat stick versus installed element. Which do you prefer, and which do you go with? What are the pluses and minuses?
Sure. Excellent question. To be honest, I had never used a heat stick until you and I initially talked, and you asked me to take a look at them. In my system, the heating element is built into the kettle. Building a heat stick, I guess my initial reaction was it's a bit of false economy because brewing with heat sticks, you're still going to have a pot large enough to boil in. And while the heat sticks are fairly inexpensive, it came out to $25 worth of materials. You pretty much got to buy similar amounts of equipment to mount the element inside the kettle. It's pretty simple stuff. It's not very complex or expensive equipment. So the heat stick is clearly more portable. It could be used over in the mash tun to raise mash temps. From my perspective, the heat. I built myself a heat stick, and I'm going to hold on to it. For me, I think it's going to be a nice insurance policy because if and when the element were ever to fail in my e-kettle, which inevitably would be mid-boil, then I would have a backup. I could just simply, go grab the heat stick, plug it in, and continue brewing.
I guess before we get too far, we should explain what a heat stick is.
Good point. Good point.
So what is a heat stick?
Basically, a heat stick, remember the brewing forums have been, devising these things for years, but a heat stick is basically your common household water heater element that is made watertight by mounting it inside a chrome sink drain pipe. And then that drain pipe is then backed with a PVC drain pipe to give you a handle so it's not so hot, and then an appliance cord out the back end. In a nutshell, that's basically it. Sounds like a dangerous thing, but as long as they stay submerged, the heater elements, they're designed to heat liquid. They're actually quite safe and simple to use. They're not going to, burn a hole in your kettle or jump out and jump up on fire at you. They're very simple devices.
Now, I guess if you had, say, an electric stove, and I used to brew on an electric stove, and it takes a lot of patience to to do that, or at least with the one I had. If you had a heat stick to kind of boost your heating capacity, that'd be a good application. When you're brewing with sticking a heating element in your wort, do you have to worry about excess caramelization with that heating element being in direct contact with the wort?
I have never ever seen any caramelization whatsoever using electric elements. And in my system and the heat sticks I built were all made with 2,000 watt high watt density elements. I've brewed everything from barley wines to pilsners, and never had a bit of caramelization whatsoever. I think the reality is when the element is down in the liquid, you've got convection currents flowing through the liquid. So the actual surface temp on that element is not really getting that hot. Water has a finite upper temperature of 212 degrees. As long as things are circulating, it's really not going to get that much hotter around the element.
Huh. So how many amps, Andy asks as well, how many amps would you have in your dream garage brewery, and how many circuits? How do you figure all that stuff out?
Well, I think first you got to back up and decide what you're able to do as far as voltage, because voltage is all part of this equation as well. Everybody's has got 120 volt outlets in their house. So the simplest thing is can I use what I have? And for 120 volt outlet, it's common to find 15 and 20 amp circuits running those outlets. Usually in their kitchen it's going to be 20. Other places it may be 15. You would almost have to trace it back to your circuit breaker box and take a look at what's actually run. If you're fortunate enough to have a 20 amp outlet, basically you can safely run up to a 2,000 watt element. If you're stuck with a 15 amp circuit, you pretty much top out at an element size of 1,500 to 1,650 if you can find them, 1,650 watt. You go much beyond that, the breaker's going to pop, and you're going to have difficulty brewing. For the dream, when you can do this, put in your own circuits. The dream ideal. Obviously, if you go to 240 volts, you get a lot more flexibility. Goes back to the old electrical equation. Watts divided by volts equals amps, and you can use math to flip those around so you can see how that works. But basically, you can get a lot more watts or energy into your pot at 240 volts than you can at 120. And the number of heating elements that are available, to use in brewing, are greatly expanded at 240 volts because that's what most water heaters actually run at, electric water heaters.
And electric water heaters generally have what? Don't they have two heating elements, most of them?
Yeah, most of them. And that's more for like a quick recovery thing, I believe. They'll have one up high so that as the hot water in the tank gets depleted, they can turn on that top element to get you that last bit of your shower.
Adam from Davenport, Iowa asks, how much time does it take to bring up to a boil and how much electricity is used, say, on a 60 or 90-minute boil. And I guess that depends on how much you're boiling. I mean, you're doing smaller size batches.
Exactly.
So how much time does it take for you to bring, say, 4 gallons up to a boil?
Yeah, for my batches, I mean, because basically I need to start out with my total system volume, which would include evaporation losses in the boil, absorption losses in the grist. For a 3.5 gallon batch, I'm normally starting with somewhere around 5 gallons, maybe 5.5 gallons of water in the kettle. From tap water, 50 degrees, throw into the kettle, it's about 45 to 60 minutes maybe to reach, really good strike temp, or maybe even a little higher. Once I'm coming out of the mash back into the kettle for the boil, basically I've reached mash out temperatures, it's going to be around 170 or so. From 170 to a boil takes me about 15 minutes.
Okay.
And my system is basically one single 2,000 watt element in the kettle, 120 volt.
So the Cajun cooker out on the patio may have you on time, but what about cost? How much electricity do you use in your brewing session?
Sure. Basically, with a single 2,000 watt element, and for an entire brew session, that element may be running 3 hours, normally less, but let's just say 3 hours. So 3 times 2, that's basically 6 kilowatt hours. And everybody can look at their last electric bill and see what that runs them. But in my neck of the woods, it's around 12, 13 cents a kilowatt hour. So basically, I'm brewing a batch of beer for under 75 cents.
So you get that you win that category.
Yeah, and the time thing is all a matter of the amount of energy you put in. A lot of folks build systems even that are limited to 120 volts. They'll put 2 elements in their kettle and just make certain they're plugging into 2 separate circuits in their house, so they're not overloading one. And obviously, more wattage in, you get quicker ramp up times and so forth. I mean, it's just like going to bigger propane burner. More energy in is going to get you to boil quicker. I mean, the key thing about the cost savings is really, I mean, electricity is generally more expensive than natural gas or propane, but the huge difference is efficiency. An element inside liquid is nearly 100% efficient. I mean, your only losses are out the side of your kettle, basically, or evaporation out of the top. Mm-hmm. Whereas even the best propane burner, the best you could hope for is 40% efficiency out of the amount of propane you're putting in.
Yeah, and depending on the weather, whether it's cold or windy, you are more or less efficient out on the patio, say, with propane.
Exactly.
One more tweet. Desiree from High Gravity in Tulsa says they've been all electric for 4 years and they love it. So there's an endorsement from somebody who's been brewing for a while. Well, let's talk a bit into some details. How do you get started? I mean, what's the first step that someone should take if they want to either switch to electricity or add electricity into their brewing system?
I get asked that a lot, especially after the article was published in BYO, because I had mentioned in there that my total system probably run me somewhere between $400 and $500 to build, and everybody's like, "Oh, well, I don't want to invest that much." But the reality is no brewer throws that all in at once. I mean, everybody goes piece by piece and step by step. Somebody starting from scratch. I mean, obviously, you need your mash tun. So you find yourself a 5 or even 10 gallon cooler on sale at Home Depot or whatever. Go to Bargain Fittings and pick up their cooler adapter to get you your valve on your cooler. I mean, you're out, $40 there for your mash tun, maybe 50. Then if you're gonna go the e-kettle, do an e-kettle route. I mean, basically, I tell people to look around for especially out here out west, look for the tamale cookers like at Target. These are basically the equivalent of the pots that come with the turkey fryers. I mean, nice big, 8 gallon aluminum pots. They're nice and tall, which tends to be more efficient with the heating with electricity, because you're not having as much heat losses around the surface. So I mean, $20 for a pot, and another $50 invested into it for your water heater element and the various bits to tie it together and put a valve on your pots. I mean, basically, for $100 and some change, you can have yourself a complete all grain system. It doesn't have to be that expensive.
So, talk about your countertop system. What are the components in that? And for those who haven't read the article, describe that system for us.
Very much as I just described, I built it the same way. I mean, I knew I wanted to go to all grain, but I didn't obviously have $500 to drop, and I wasn't sure exactly what I wanted initially. So I started by building myself an electronic kettle, which was nothing more than like I said, a $20 aluminum pot, and mounted the 2,000 watt heater element in it, and that was basically my brewing system. I had a cooler that I was doing basically. I didn't even have it set up to a true sparge system of the cooler. I was basically using a giant grain bag and doing grain bags to sparge inside or to mash inside the cooler, and then dump into the kettle and boiled from there. Next step was to build myself a proper mash tun, which like I said, put a valve on it, and a stainless the sheath from a stainless braided washing machine hose on the inside to basically be my manifold for the sparge, and just use gravity simply to flow from that into my kettle and boiled. The final stage of my system is basically, I wanted to take this thing to the final level where I could automate it, manage temperature control, and I wanted to be able to integrate cooling into my system. I mean, the one thing about thinking about brewing indoors versus outdoors. I mean, outdoors is no big deal if you make a mess. You need to make a hose connection. If a little wort or water leaks out, it's no big deal. In the kitchen, you're liable to make the wife very unhappy with that kind of stuff. So, I basically designed a system that required no plumbing changes below the water level or below the wort level. So it's very clean to use. So the complete system basically is a mash tun that sits on top of a Home Depot bucket, and inside that bucket is a coiled inside it is a counterflow chiller, and down at the bottom sits a March pump. And then alongside of that, I set my electronic kettle, and into the kettle I had installed a temperature probe that feeds the little electrical box that has a PID, which is basically just a little computer that basically manages the electricity going to the element based upon the temperature input from the probe. So I got some temperature control. When the system's in operation, basically, like during a mash, the mash tun will slowly drain into the kettle. The kettle is, if the PID is managing the temperature of the wort in the kettle, say I want the mash to stay at 152, so it will meter out the electricity to the element to make sure that temperature is kept. Then the pump draws the wort out of the kettle back up onto the top of the mash, and it recirculates. So I have a continuous recirculation of the total wort. The advantages of that is basically you don't have to worry about vorloffing at the end. I mean, basically from the get-go, you've got a nice, clean mash bed set. It allows me to ramp up temperatures. I mean, I can do step mashes where say I want to start a mash at 149 degrees and then ramp it up to 156 for a while, and then finally I can just set it up to 170 and let the mash go all the way up to mash out temperature. And at that point, shut the pump off, and then gravity takes care of flowing all the wort back into the kettle and start the boil. The beauty of the no sparge system, as I mentioned before, is basically it really does make the math simple. A lot of people are concerned about losing efficiency, and if this was truly a no sparge system, then yeah, your efficiency is pretty poor because you're taking what comes out of your first runnings out of your mash, and that's it, you're done. Mm-hmm. But in my system, you're compensating by putting the full volume into it up front. So while I may mash at, 1.5 or 2 quarts per pound, once I start the recirculation, I've got several gallons of additional fluid that are circulating through. So the overall pre-boil gravity reaches equilibrium throughout the system as it recirculates. Huh. So it ends up making the efficiency not nearly as horrible as most people would think. I generally hit in the 70% range, on all the beers that I brew. So mm-hmm. That's not as high as the traditional fly or batch spargers get, but the reality is it's simpler for me. It takes one vessel out of the equation, and making up the difference of the 10 percentage points that traditional brewers have is an extra pound of grain.
Yeah,
another $1.50.
Yeah. Well, it sounds like a fun project, and your BYOR article is still out there on the web. I Googled it before we talked, so I can put a link to that in the description of this episode on basicbrewingradio.com, and I can also put a link to your website where you went through the process of building the heat stick. Now, you took a look at another web page to get the starting instructions on building the stick, but you had some improvements as well, right?
Yeah. I think I don't remember the fellow's name, but everybody calls it the Cedar Creek site because that's his URL for it. He was kind of like probably one of the biggest proponents of heat sticks out there. A lot of people have built heat sticks based off of his great instructions and pictures there. But the tinkerer in me could never leave well enough alone. And there were several design aspects of his that I didn't personally care for. One of the big ones was he basically drills a hole in the bottom of the drain pipe and then runs a brass screw into it for securing the ground wire for your electricity. And to me, it just didn't make sense, punching a hole into something that's going to be continually below, the water level. Mm-hmm. And so I just make it simple. I run the ground lead back up to the top of the drain pipe, and then just wedge it between the actual chrome pipe and the plastic pipe coming down. It makes a nice secure fit. Should be more than adequate for the ground, and you're keeping everything nice and watertight.
So what are the parts that we will need to build a heat stick?
Water heater element, a 12-inch, straight chrome drain pipe with a slip fitting. It basically means it has a threaded end, a 6-inch PVC slip drain pipe, a 1-inch PVC end cap, and a couple-inch piece of 1-inch PVC pipe if you happen to have some laying around, some JB weld, and then one other modification I made to his was basically abandoning the slip nut that comes with the chrome pipe in favor of one that's called a slip reducer. It's basically meant for adapting 1.5-inch drain pipe down to 1.25-inch pipe. And I checked it, several Lowe's in the Colorado area around here, and all of them carried this part. It was a couple of bucks. The key thing about it is the actual threaded portion of the water heater element is 1.25 inches. So this slip nut actually has a much better fit against the water heater element and secures it much better to the drain pipe.
Now you say JB weld, and that's an epoxy, right?
Yes. Yep. The key thing we're after there is to basically find a way to make all of these electrical connections, which are obviously going to be down below water level, nice and watertight. Make sure no water can get into them. And seeing online, I've seen a number of people that had tried to find building heat sticks, tried to devise a number of ways to do this. I saw some that were basically like dipping the entire exterior of the heat stick in JB weld. It looks like a god awful mess. Mm. And the problem is if anybody's ever worked with the JB Weld, I mean, it's great stuff, but it's very thick. It's very viscous. It doesn't really pour. And I thought, well, the ideal solution would be if we could find a way to make this stuff pourable, we can just pour it into the top of the heat stick, let it flow down, and set and just, pot all of these connections nice and watertight. And so I did a Google for, thinning JB Weld, and I think one of the first hits was JB Weld's own website with frequently asked questions, and it said you may use up to 1 teaspoon of acetone while you're mixing your JB Weld to make it pourable.
Huh.
And I'm like, that's perfect. And for folks who I don't have acetone, well, go sneak your wife's nail polish remover, because that's probably what it is.
If you've ever glued your fingers together with the super glue, you're probably already familiar with that.
Exactly. But that made it nice and pourable, and so it just poured nice, like maple syrup down into the bottom of the heat stick, and completely covered all of those electrical connections. So even if there was some sort of condensation or any sort of liquid somehow found its way inside there, it's not going to short out or cause a problem with your electrical hookup.
So step us through, how do we put all those parts together? What was the the important things that you found that were the most tricky?
Probably the most important thing is this. I mean, you're basically stringing all of this stuff onto an electrical cord, and if you forget a piece, there's no undoing it. So I think the key thing is to get all of your pieces lined up and thread them all onto your electrical cord up front before you start making any commitments with with the JB Weld or gluing or so forth. But basically, start with your electrical cord. One of the things that I'm an IT guy, so I've got boxes of 20 amp cords around for servers and routers and so forth. So, if you work at a place that's got IT folks, maybe bribe them with a couple of home brews for a nice 20 amp power cord, and that saves you from spending $15 on one at the hardware store. Basically, snipped off the female end. I drilled a hole through that 1-inch PVC end cap, threaded the appliance cord through the end cap, and then just piece at a time, as I've got pictured on the website, just make sure you got all the pieces together, and then work the assembly back from the element back. And it really is. I mean, this is outside of waiting for the JB Weld to set overnight. This is maybe a 15-minute operation to build one of these things.
Huh.
It's really simple.
So, how do you test it? How do you make sure that you're not going to shock yourself when you stick it in your brew pot?
Well, first, I mean, once you got it, the JB Weld is set on the electronics at the bottom of the heat stick. I would suggest before gluing the handle together, go ahead and just drop the heat stick down into a bucket of water, unplugged. Just let it sit for a few hours, and then you can use a flashlight, look inside there, make sure everything's nice and dry as you would expect, before you do final assembly. But the key thing is just remember to always use the GFCI outlet when you're using a heat stick, because if anything does short out or go wrong with it, that's going to trip instantly. I mean, you'll never feel a shock before that trips.
Now, you don't want to plug in the heat stick when it's not in fluid, though, right?
Exactly. And that was probably my other big sort of complaint with heat sticks, is you've really got to be mindful in using them. While they'll last a long time and be very reliable while they're submerged, and in fact, while the heat stick is submerged, there's nothing visual to see. I mean, it's not like you're going to see plasma streams or weird stuff coming off the end of this water heater element. It's just heat. But if you do pull it out of the liquid while it's plugged in, it will very quickly glow red hot, and after a short while, it will just burn out. Mm. Anybody's had an element on their electric stove burn out has seen the similar effect. Mm. These things don't like to be dry fired at all, so you got to be very mindful of that, making sure that it's submerged before you plug it in, and that you unplug it before you remove it. Which is, I think, one of the things why I'm more in favor of doing a proper electric kettle, because a lot more of that thought process is out of mind for you. I mean, you're not going to run the kettle until there's something in it.
Mm-hmm. You also say in your notes at the bottom of your webpage, don't drape the cord across a path of traffic.
Yep.
Because if you have one of these heat sticks sticking in your, and well, I guess it goes for an electric kettle as well. You don't want to put it somewhere where somebody might trip over it and spill boiling liquid over themselves or somebody else or anywhere.
Yeah, no, I think that was the concern of mine, is that, I mean, and some of the difference between with a heat stick, draping out of the top of the kettle, it basically gives a more of a leverage point against a full kettle versus, a cord going into the bottom of the kettle. I think it's less likely to tip it over. But either way, I mean, you got to use some real common sense and make sure these, wires are out of the way of traffic and can't be tripped on and so forth. I mean, it's just, basic common sense.
Right. But in an instance where you might be sipping a couple of home brews while you're brewing, you might want to plan ahead for the
Absolutely.
And then you say that rust, you might see some rust at the base of the water heater element, but you shouldn't worry.
No, and that's actually been an interesting discussion among a number of us electric brewers, chasing this down. In my e-kettle, which is an aluminum pot, I mean, basically aluminum turkey fire pot, with the water heater element in it. I mean, I've been using the same water heater element now for 18 plus months, and I've never seen a trace or hint of rust in mine. Whereas other electric, brewing folks that have basically, mounted water heater elements inside, stainless kegels or stainless pots, have noticed, some rust appearing, within their first or second brews. And, a number of us, speculate back and forth. And the fact is that, a proper water heater where these things normally use have a sacrificial anode in the top, basically to, prevent, rust accumulation and so forth in the water heater. And, folks brewing in all stainless type setups don't have that. Whereas in my setup with the aluminum pot, the pot itself is basically acting as the anode, so I'm not seeing the rust. So it's an argument in favor of using an aluminum pot, which is sort of ironic after the taboo for so many years.
Well, as I've said before, I use an aluminum pot myself, and Steve does too, and we like them. So, I guess, I mean, is there any maintenance that has to be done on? I mean, if you do see rust on your heating element, I guess you'd want to try to get that off.
Yeah, in the few test runs that I ran with the heat sticks that I built, I did see a little bit of surface rust. But I mean, once I took them out, I mean, it was just, a simple wipe with a rag and it come right off. I mean, I mean, there's certainly nothing harmful about a little iron. I mean, it's, I don't think it's anything at all to be concerned about. The element themselves, I mean, can need a little bit of attention, and that, I mean, make sure that, especially in an e-kettle, that the element is thoroughly cleaned when you're finished brewing. I know on mine, when I do, really heavily hopped beers, like, I did a Pliny the Elder clone, where there's, darn near a pound of hops going into it. The hop level at the bottom of the kettle reached the point where, when I emptied it out, I could see, where some of it had actually stuck to the element, or, just caused a bit of a film on the element. So, you want to make sure you get that stuff cleaned off, because if too much crud or whatever will accumulate on the element, you run the risk of it overheating because it can't get good contact with the liquid that it's supposed to heat.
That's a good point. And you just want to clean out your brew pot. I mean, no matter what you're using, you don't want to leave crud on there from batch to batch. That's just not a good practice.
Absolutely. In my Brutus 20 setup, I mean, cleanup, that's the other thing I get asked a lot about, is how difficult it is to clean this stuff up. And it really is simple. I mean, after the brew session's done, I mean, I do a quick rinse of my kettle, then turn around and, fill it with a couple gallons of hot water and dump in a scoop of PBW or OxyClean, if I have, whichever I got handy, and then just use the pump then just to recirculate that cleaning fluid through the counterflow chiller and back into the kettle. Let that run for 10 minutes, dump it all out, fill the kettle with fresh water, and then pump it into have it pump again through the counterflow chiller and dump it into the sink. So I mean it's actually easier in many ways to clean up than regular systems.
So is there anything else that we haven't covered on brewing with electricity?
Well, I guess taking it to the next level. I mean, there's a number of really high end and large scale home brewing systems. I mean, people doing 10 plus gallons and using fancy names like RIMS and HERMS. And probably RIMS is the most interesting one with electricity. Basically, RIMS stands for a recirculated infusion mash system. And this is kind of cool in that they will take their mash tun and out of the mash tun run the wort through a pump and then into basically a tube that has a water heater element mounted inside the tube. And then the output of that will go back into the mash tun. So basically they've got this dedicated heating element that's directly warming the wort and circulating it through the mash. I've seen some huge systems, and some people really love that type setup. It allows them to very rapidly, change mash temperatures and so forth, and get some really high quality wort. So you see electrical brewers that really go all out, and I mean they'll do, they'll run dedicated, 30 or even 50 amp, feeds into their garage, and have kettles with 10,000 watts of power in them. Electricity really is scalable. I mean, you can go from, doing small batches like I do all the way up to the big stuff.
You're a home brewer when the lights in your neighborhood dim when you're brewing a batch of beer.
Exactly. Yeah, but ultimately, I think that the takeaway that I like to have people go with is to give electricity a second thought. I mean, it can be cost effective both from a construction and an operation standpoint, and it really can be quite safe. I see a lot of advantages compared to propane personally, and the fact is, I love brewing indoors. If you're fortunate enough to have a spouse who can tolerate the interesting aromas, can't beat having a batch of beer brewing while you're in the next room watching the baseball game.
I hear you. Well, Jeff, this has been fun. I appreciate your taking time.
Glad to do it, James. Glad to talk to you.
Well, thanks again to Jeff. You can find links to both Jeff's BYO article and his instructions on making a heat stick in the description of this episode on basicbrewingradio.com. Or if you're listening to this on your iPhone app, just tap the little extras button on the upper right-hand corner of your screen. And I'll see if I can attach them there. If you have any brewing questions, show suggestions, or just want to say howdy, write to james@basicbrewing.com, or just fill out the contact form on basicbrewing.com. And please don't forget to tell us where you're from. Our 2010 Brewers Logbooks, the supply is dwindling, but there's still some. You can get yours. You can also check out our Reinheitsgebot is a 4-letter word shirt on our shop as well, along with our DVDs, Introduction to Extract Home Brewing, Stepping into All-Grain, Low-Tech Lagering and Decoction Mashing, and Introduction to Wine Kits as well. And we have combo deals on our site to save you a couple of bucks if you buy more than one DVD at a time. And also you can see a listing of the fine folks across the country who sell our DVDs on basicbrewing.com. And if there isn't a vendor in your area, you can order them online in our online shop at basicbrewingshop.com. Thanks to everybody who's continued to click on our Amazon.com link. We appreciate the support there. Our featured products this week that were purchased through the link are Under the Influence, the unauthorized story of the Anheuser-Busch dynasty, and Flip Ultra HD Camcorder, 120 minutes, black. Thanks again, everybody. And remember, I can't tell who bought what, so no worries there. Just click on the Amazon.com logo on our site the next time you feel like Amazon shopping. We appreciate your support. And we also have those links to the American Homebrewers Association and Brew Your Own magazine as well. That's all. Until next week. Until then, thanks for listening, everybody. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by our buddy Kelly Dodson down in Austin, Texas. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. So long.